Kia ora, Year 12. This is a differential equation question from today's test, and I like it because I think it makes you work quite carefully through what to do with the constants of integration. So when you first look at it, you should be able to see straight away that we've got to do some separating the variables, right? And we have to do that in almost every DE problem that we see. So what I've got here is I need to get the y stuff over to this side and the x stuff over to this side. So it's just about right, but I'm going to... I'll just write it out first. So we've got dy by dx is equal to 6y e to the 3x over 2 plus e to the 3x. So if I look at this before I get going, I should be able to see that the derivative of this bottom line is going to be 3e to the 3x. And I've nearly got that sitting up here, right? I've got 6e to the 3x sitting up there. So I think the best way to do this question, which is what I've done in this video, which is the cleanest, is this. Let's split the 6 up into 2 times 3y e to the 3x. So we don't have to do that, but if you do that, I think you can see that if you keep this x stuff here on this side and keep the constant of 3 with it and whoosh the 2y over to the other side, things should go quite well. You can just divide through by 6y, right? It will all come out, but it will just be a little bit muckier. So what I get here is I'm going to have 1 over 2y dy is equal to 3e to the 3x over 2 plus e to the 3x dx. Okay, so I'm timesing both sides through by this. That's why it ends up here. And I'm dividing both sides through by 2y, and that's how come that's over here. Now I'm ready to integrate on both sides. So here I'm integrating with respect to y, and over here I'm integrating with respect to x. Remember that I just end up getting one constant of integration. Now there are different smart ways to do constants where you've got logs, but I'm just going to do it a really, really slow way. So on the left-hand side, I've got 1/2 times the natural log of y, and I'm not putting my constant in there because I'm going to collect it all up on this side. This integral is simply the natural log of 2 plus e to the 3x, okay, because of the way I split it up there. So I've got here, I've got the function in the bottom line and the derivative in the top line. We're always on the lookout for that pattern, f dash of x over f of x. So I've got that, and then I've got plus c. Now, if I write that constant, so this is an arbitrary constant, I can write that, instead of writing it like that, as log of c. And when I do that, that means that I can combine these two things together as the natural log of c times 2 plus e to the 3x. Okay, that's using my level 2 NCEA log rules. And over here, that gives me the natural log of the square root of y. Now, if you take a look at what we've got here, what that means is I've got the natural log of blah, blah, blah is equal to the natural log of blah, 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 blah. That means I can exponentiate both sides, do e to the power of both sides, and I get root y is equal to c times 2 plus e to the 3x. So we're getting pretty close to the end here. I've just about got, what do I need to get? I have to find an expression for y in terms of x, right? And we're given a value. So we're told that when x is 0, y is 36. Now I can substitute that in up here if I want to, but I've just chosen to hold off and do it down here. So substituting now, we know that 0, 36 can go in. So the square root of 36 is 6. And that gives me 6 is equal to c times 2 plus e to the power of 0. And so 6 is equal to c times 3, giving me c is equal to 2. Now, putting that back into here, we're just about getting an expression for y. So root y is equal to 2 times 2 plus e to the 3x. Squaring both sides gives me y is equal to 4 times 2 plus e to the 3x squared. And that's going to be my final answer for that question. Let's just check that we've answered what we needed to do. Yep, we had to give an expression for y in terms of x. So there you go, 6 marks. I do think that's on the harder side of basic separating the variables questions, just because of getting used to working with the constants. And I think it's the old delta work that we did that was quite good on that. Although some of the work in exercise 9b in the textbook will also help you. So if you've still got questions on that, let me know. And when you get your test back, just make sure that you go through this question again until you can do it easily. Thanks for watching.